Welcome to Tutorial 8. So far, all of the tutorials today have primarily focused on data from paleoclimate proxy-based reconstructions. Another really useful tool for reconstructing paleoclimate are climate models. In this tutorial, we'll explore the value of climate models and we'll practice plotting and comparing paleoclimate model data to paleoclimate proxy data. Climate models use mathematical equations to characterize how energy and matter interact in different parts of the ocean, atmosphere, and land, and simulate changes in the climate system. There are models that do this for current and future climate, and there are also models that create these simulations to reconstruct past climate. During the next 2 days, you'll learn more about how climate models work and future climate projections using models. But for today, we'll focus on paleoclimate models. The figure on the left is showing changes in atmospheric CO2 and surface temperature over the past 60 million years. The black lines are proxy-based climate reconstructions, and the colored lines are future projections of temperature and CO2 change. And the maps are all simulated temperatures from paleoclimate models. If you compare the time series of reconstructed temperature in CO2 to projected temperature in CO2, you'll notice that there are periods in Earth's history where atmospheric CO2 concentrations and global temperatures were as high and as warm as are projected for the future. Similarly, if we compare the paleoclimate model simulations represented in the maps to the projections of temperature change in the maps on the right, you can see that there are also periods in the past where temperature was analogous to future changes. For example, the early Eocene looks very similar to the projected temperature for 2300. This highlights one of the main reasons why paleoclimate models are important, because understanding past changes in climate states can help us understand future changes in climate. Specifically, paleoclimate models can help to assess climate forcings of proxy-based reconstructions, and they can also help to validate and improve future model projections by comparing climate signals between proxies and models. Paleoclimate models are useful for assessing forcings of climate because the models can simulate the response of the climate system to specific forcings such as greenhouse gases, solar insolation, and ice volume. This forcing information is something we can't learn from proxies alone, so comparing paleoclimate model simulations to proxy reconstructions can help to link the forcing processes to the distinct proxies. For example, this figure on the left is showing simulated and observed temperature from 1900 to 1990 on the top, and the model forcings below. From this, we can see that greenhouse gas concentrations were the dominant forcing of temperature over this time period. Additionally, comparing climate signals between proxies and paleoclimate models can help to validate and improve future model projections. If models simulate past climate changes correctly when compared to proxy reconstructions, this can help to validate their ability to predict future changes. For example, the top panel in the figure on the right is showing changes in surface temperature as recorded by proxy reconstructions, and the panel on the bottom is showing simulated changes in surface temperature from paleoclimate models. In this tutorial, we'll explore global mean surface temperature data from the Paleoclimate Modeling Intercomparison Project 3, or PMIP3. And these are simulations of past temperature over the past 1,000 years. We'll compare these model simulations to a proxy-based temperature record from Lake Tanganyika in tropical East Africa to assess similarities and differences in proxy-based versus model temperature reconstructions.